Hello everyone, good evening. Today we will solve some more JEE Mains previous year questions on the chapter Gravitation. So any doubts you have, steps, then please write it in the comments, which will always be clarified. So here it is told that in statement 1 for a planet if the ratio of mass of the planet to its radius decreases, the escape velocity of the planet also decreases. So escape velocity we know that is equal to 2 gm by r. So this means the escape velocity is proportional to the ratio, the square root of the ratio of mass and the radius. So if the ratio of mass to its radius decreases, then the escape velocity also increases, then the escape velocity also increases. It is true. So the statement one is true. Escape velocity is independent of the radius of the planet, which is false. So statement one is correct, but statement two is incorrect. So option B is the correct answer. When it is told two planets A and B of radii r and 1.5 r have densities rho and rho by 2 respectively, the ratio of acceleration due to gravity at the surface of B to A is acceleration due to gravity, that is given as Vm by r square. So mass is the density into volume by 3 pi r cube divided by r square. So it is equal to G 4 by 3 G pi into rho r. So it means G is directly proportional to the density into radius. So therefore, the value of G at the surface of B to the value of G at the surface of A, that is equal to rho A into R A by rho B into R B. No, rho B into R B by rho A into R A. So therefore, G B by G A, that will be equal to rho of B, that is rho by 2, to R, the radius of B, that is 1.5 R, divided by the radius, the density of A, that is rho, the density of B, that is, and the radius of A, that is R. R will cancel, rho will cancel, so it is 1.5 by 2, that is, so 1.5 is 3 by 2, so 3 by 4. So the required ratio is 3 is to 4. So option D is the correct answer. Then it is told that planet having mass 9 me and radius 4 re, where me and re are the mass and radius of the Earth respectively, has escape velocity in kilometer per second being by. So you know that escape velocity on the surface of Earth, that is equal to root 2 gme by re, that is equal to 11.2 into 10 power 3 meter per second, which is equal to 11.2 kilometer per second. The escape velocity on the surface of that planet, let's call it as V dash, EP, I can say, that is equal to root over 2 G MP into pi RP, where MP is the mass of that planet and RP is the radius of that planet. It is 2 root of 2G into mass of the planet is 9 AV, by radius of the planet is 4 RE. So it is the square root of 9 by 4 into square root of 2 G ME by R. Equal to 3 by 2 times the escape velocity on the surface of Earth. It is 3 by 2 times 11.4 is equal to 2 5 is 10. So 3 into 5.6 is 3 6 18. But 16.8 kilometer per second. Option C is the correct answer. Then it is told the ratio of escape velocity of a planet to the escape velocity of Earth will be given mass of that planet is 16 times the mass of Earth and radius of that planet is 4 times the radius. So therefore, the escape velocity is given as escape velocity on the surface of Earth is 2 gm by r. So therefore, the escape velocity is directly proportional to square root of m by r. So therefore, the ratio of escape velocity of that planet to the escape velocity on the Earth. So dp by dv have been asked. So this is equal to square root of mp by rp by square root of me by rp, which is equal to square root of mp by me into square root of re by rp. So mass of that planet is 16 Ne, 16 Ne by Ne into Re by the radius of the planet is 4 Re. So Re will cancel, Ne will cancel. So therefore, dP by dE, that is equal to square root of 16 by 4, which is equal to 4 by 16, which is square root of 4, which is 2. So 2 is to 1. So ratio of the escape velocity of a planet with respect to system of the Earth is 2 is to 1. So option D is the correct answer. Then here it is told two satellites A and B move around the Earth in the same orbit. Two satellites A and B move around the Earth in the same orbit. A and B in the same orbit. The mass of A is twice of the mass of B. So mass of A I can take 2m and mass of B I can take m. The quantity which is same for the two satellites will be quantity that is same, that is the orbital speed. Since the orbital speed is given as root over gm by r, means it is independent of the mass of the satellite. It only depends on the mass of the Earth and the radius of the orbit. So since y kinetic energy will not be same, since y kinetic energy is gmm by 2r and potential energy is minus gmm by r, so it also depends on the mass of the satellite, and kinetic energy also will depend on the mass of the satellite, and so the total energy will be minus gmm by 2r, which also will depend on the mass of the satellite. But the orbital speed is equal to root gm by r, which is independent of the mass of the satellite. So only the speed or the orbital speed will be same for the two satellites, even if their mass is not the same. A spaceship is there of mass 2 into 10 power 4 kg is launched in the circular orbit close to the Earth's surface. The radius of the orbit is approximately same as the radius of the Earth. The additional velocity to be imparted to the spaceship orbit to overcome the Earth's gravitational field will be additional velocity to be imparted. That means we need to find the escape velocity and at that orbit, which is root over 2 gm by r is re is equal to 11.2 kilometer per second, and the orbital velocity that is equal to root gm by re is equal to escape velocity by root 2, which is equal to 11.2 by root 2, the approximately 7.92 kilometer per second, or I can say 11.2 by root 2 kilometer per second. So therefore, the additional velocity that is required, which is delta v, that is ve minus v naught, which is equal to 11.2 minus 11.2 by root 2, which is equal to 11.2 to 1 minus 1 by root 2, which is equal to 11.2 into 2 minus 1 by root 2 kilometer per second is equal to 11.2 by root 2 is 7.9. So 7.9 into root 2 minus 1 kilometer per second. So option A is the correct answer. Here it is told the radii of two planets A and B are R and 4R, and their densities are rho and rho by 3 respectively. The ratio of acceleration due to gravity at the surface. Yeah. So GA by GB, that will be equal to the radius of that planet A, that is GA because if Cm by V is equal to Gm by R square, G into M, that is rho into 4 by 3 pi R cube divided by R square, which is equal to 4 rho by 3 pi G into R. So G is directly proportional to the density into radius. So therefore, Ga by Gb, that will be equal to rho A into Ra by rho B into Rb. The density of A, that is rho, and radius of A, that is R. Density of B, that is rho by 3, and the radius of B, it is 4 out there. R will cancel, rho will cancel, so that is 1 by 4 by 3, that is equal to 3 by 3. So the required ratio is 3:4. Option D is the correct answer. When they store the time period of a satellite revolving around Earth's surface at a height equal to R will be the time period of a satellite revolving above Earth's surface at a height equal to R will be. The time period is given as, we know that V naught, which is the orbital speed, that is equal to Gm by R. I can say it is equal to gr. So V naught, I can say it is 2 pi R by T equal to, I think, R plus H actually. This is gr square by gr square by R plus H. Height is R, so this is 2R. So this is equal to root over gr by 2. The orbital velocity so orbital velocity, that is 2 pi R by T, is 2 pi into R plus H by T, that is equal to root gr by 2. Now H is R, so this is 2R, so 4 pi R by T, that is equal to root over gr by 2. So T will be equal to 4 pi R divided by root gr by 2. So this is equal to square root of 2 into so 16 pi square R square by G R. G is pi square. Pi square will cancel. R will cancel. So this is 16 to the 32. This is root over 32R. So the time period is root over 32R. So option A is the correct answer. Then it is told given below are two statements. Rotation of the Earth shows effect on the value of acceleration due to gravity. So it is true. Since by G at any latitude, at any angle, any latitude theta, that is given as G is there is a centrifugal force. It's here we have latitude. If the latitude is theta, then this radius is r cos theta. Is rotating, so there is a centrifugal force acting, which is m omega square r cos theta. We will take the component of this, which is m omega square r cos square theta. So the weight, that is mg dash, that is equal to mg minus m omega square r cos square theta. So it means g dash will be equal to g minus omega square r cos square theta. So if the latitude is theta at that place, then the rotation of the Earth will have an effect on the value of acceleration due to gravity. Means the acceleration due to gravity will decrease um, with the effect of the rotation. The statement 2 is the effect of rotation of the Earth on the value of G at the equator is minimum and at the pole is maximum. So which is wrong since why? Wrong since why? At at the equator, the angle theta is 0 degree. So cos square theta is maximum here. So the value of G is minimum at the equator. And at the poles, the angle theta is 90 degrees. So cos square theta is minimum there. So the value of G is maximum at the poles. But at the equator, it is minimum. At the pole, it is maximum. Okay, so it is true. So the statement 2 is also true. Statement 1 is also true. Both statement 1 and 2 are true. So option C is the correct answer. Then it is told two satellites of masses m and 3m revolve around the Earth. The circular orbits of radius r and 3 are respectively. The ratio of orbital speed of the satellites is r. So the orbital speed is given as root over 2gm by r. 2gm by root over gm by r. R is the orbital radius and m is the mass of the Earth. So it means the orbital speed is independent of the mass of the satellite. So the orbital speed is inversely proportional to the square root of the orbital radius. So therefore, I can say V ratio of the orbital speeds is now say V1 by V2, that will be equal to root over R2 by R1, which is equal to root over 3R by R. So it will be equal to root 3 is to 1. So it is root 3 is to 1. So option B is the correct answer. It is told, assuming the Earth to be a sphere of uniform mass density, the weight of a body at a depth d is equal to r by 2 from the surface of Earth. If its weight on the surface of Earth is 200 Newton will be. So the G value at the depth d, that is given as G into 1 minus d by r, where G is the value at the surface. So the weight mgd is the weight at the depth d, that is given as mg into 1 minus d by r. So it means the weight at the depth W dash, that is equal to the actual weight on the surface into 1 minus d by r. So here d is equal to r by 2, so it will be 200 Newton into 1 minus r by 2 r. So it is 1 minus half, that is half, so it is 100 Newton. 100 Newton will be its weight on at a depth of r by 2 from the surface of Earth. Option A is the correct answer. Then it is told the acceleration due to gravity at a height h of the space h is much less than r is. So we know that the value of g at a height g dash is given by g into r square by r plus h whole square. Now we can set it as g into g by 1 plus h by r in power 2, which is g into 1 plus h by r in power minus 2. So if h is much less than r, then we can apply the binomial approximation, that is g dash to approximately equal to 1 minus 2h by r. Means this exponent will come here. So option A is the correct answer. And it is told the orbital angular momentum of a satellite is in when it is equal to in a circular orbit at a height h from the surface. If the distance of the satellite from the Earth's center is increased by 8 times to its initial value, then the new angular momentum will be. So we know that the angular momentum will be equal to m v naught into r, where r mdr. So here it is L. So here r is at a height h, so r is equal to r plus h. That means B is equal to, as you know, is root gm by r plus h. Therefore, L is equal to m into root gm by r plus h into r plus h, which will be equal to m into root over gm into r plus h. Well, now if the distance from the earth center is increased to 8 times of its initial value, so now L dash will be equal to m into root over gm by 8 into r plus h, 8 times now, into 8 into r plus h, then b dash into r dash, then b dash orbital, new orbital speed into new orbital radius. So this would be equal to 8 by root 8 into m into root gm into r plus h, which is equal to 8 by root 8 into L, which is root 8 L. New angular momentum. The distance of satellite is increased by 8 times of the initial vector. Then the new angular momentum will be. It is coming root 8 L circular orbit. You know that L is equal to m omega r square VR. Now m omega, that is 2 pi by t into r square. T square is proportional to r cube. T square is proportional to r cube. So I can say that T is proportional to r power 3 by 2. I can say L is directly proportional to r square by r power 3 by 2. Means L is proportional to r power 2 minus 3 by 2. So r power r. That L is proportional to r power r. Means L dash by L, that is equal to r power r, which is 8r power r. It is increased to 8 times its initial value by r power r. It is equal to root 8. So which is equal to root 8 L. So it means here none of the options are coming correct. Here it is told, statement 1, if E be the total energy of a satellite moving around the Earth, then its potential energy will be E by 2. E be the total energy of a satellite moving around the Earth, then its potential energy will be E by 2. So we know that the total energy is given as minus Gm by 2R, and the potential energy that is given as minus Gm by R is obviously equal to 2 times of E. So it means statement 1 is false. Statement 2 is the kinetic energy of a satellite in an orbit is equal to half the magnitude of the total energy. But kinetic energy is Gm by 2R, which is same as the magnitude of the total energy. So it means statement is also correct. So both statement 1 and 2 are incorrect. So option A is the correct option. When it is told the weight of a body on the earth is 400 Newton, weight of a body on the earth is 400 Newton, then weight of the body when taken to a depth half of the radius of the earth will be weight of the body when taken to a depth half of the radius of the earth will be. Weight of the body when taken to a depth half of the radius of the earth will be. So the new weight that will be equal to the actual weight into 1 minus d by r, since the g at a depth that is given as g into 1 minus d by r. So weight of the body when taken to depth half of the radius of the earth. So d is equal to r by 2. So w into 1 minus r by 2 by 2 by r. So that is 1 minus half, that is half. So that is w by 2, which is 200 Newton. The new weight of the body is 200 Newton at that depth. Option B is the correct answer. Then it is told the weight of a body on the surface of the earth, that is 100 Newton. The gravitational force on it when taken at a height on the surface of the earth equal to 1/4 the radius of the earth is the gravitational force when taken at a height equal to 1/4 the radius of earth. It is r by 4. So we know that the new weight will be equal to the actual weight into r square by r plus h whole square. Since we know that the g at a height is given as g into r square by r plus h whole square. So the new weight will be equal to the actual weight, that is 100 into r square by r plus r by 4 whole square is equal to 100 into r square by this 1 plus 1 by 4, that is 5r by 4 whole square. So this will be equal to 100 into r square into 16 by 20, 16 by 25 r square. R square cancel, so 25 for the 100, so 16 for the 64. So 64 Newton will be the weight of the body at a height of r by 4. So option B is the correct answer. It is told choose the incorrect statement from the following. The linear speed of a planet revolving around the sun remains constant, which is wrong, which is false. Since why the linear speed will continuously change at every instant, since its magnitude is remaining constant, but its direction will continuously change. And when a body falls towards Earth, the displacement of Earth towards the body is negligible, which is true. The speed of a satellite in a given summer orbit remains constant. That is also true. The speed will remain obviously constant since orbital speed is given as equal to gm by r, which always remains constant. And for a planet revolving around the sun in elliptical orbit, the total energy of the planet remains constant, which is also true. So only option A is the wrong statement. So option A is the correct answer. Then it is told even below are two statements. One is given as assertion, other is the reason. So assertion is given as Earth has atmosphere, whereas Moon doesn't have any atmosphere, which is true. But the escape velocity on Moon is very small as compared to the Earth, which is also true. So since the escape velocity of the moon is very small, so since we know that the thermal velocity or the root mean square speed of any gas is more than the escape velocity on the moon. So it means there, so hence there is no atmosphere on the moon. So this had to be told here. So it means R and both A and R are true, but R is not the correct explanation of A. So option B is the correct answer. You can also tell that since it is told it is very small. Okay, so okay, so it will be option B or C. I think it will be C. Since why we can say that it is told that escape velocity of the moon is very small as compared to Earth. So hence the root mean square speed of any gas molecules will be obviously more than the escape velocity on the moon. So hence there is no atmosphere on the moon. So option C will be the correct answer, that R is the correct explanation of it. Then it is told a planet has double the mass of the Earth. So mass of the planet is twice of mass of Earth. Its average density, it is equal to the density of the Earth. So their density is same. Let's take it as rho. Suppose then an object weighing W on Earth will weigh on that planet how much? So if the weight of an object on the planet, that is on the Earth, that is equal to mg, then mass of the object will not change, but the weight will change since the value of g will change. So the g dash on the planet, if the value of acceleration due to gravity on that planet is g dash, and the weight on that planet will be mg dash. Now g dash would be equal to root over g into mass of that planet by radius of the planet whole square. Now this I can write square root of g into density into volume is 4 by RP cubed divided by RP square. So that is equal to root over rho 4 by 3 pi g RT. Now we can say that g is equal to actually root over g into 4 by 3 pi rho to RT. So the radius is double the mass. Double the mass. Density is same. That means we can say density of that planet into 4 by 3 pi RP cube, that is equal to twice of density of Earth into 4 by 3 pi RE cube. So this will get cancelled. So I can say that density also will get cancelled. So RP cube, that is equal to twice of RE cube. So therefore, can say radius of that planet is 2 power 1 by 3, means cube root of 2 into radius of Earth. You can say this will be density of the planet into 4 by 3 pi g into 4 power 1 by 3 for 1 by 3 times RE. This will be equal to the density of, so this is equal to g. So this will be 2 power 1 by 3 power of 2 times the mass of Earth. Sorry, this is wrong. It's not square root is from there. Gm by r square. So this will be equal to g into 4 by 3 pi rho into RE. So this will be equal to 2 power 1 by 3 times g. Therefore, the new weight also will be 2 power 1 by 3 times mg, which is the actual weight. So it is 2 power 1 by 3 times the weight. So option D is the correct answer. Then it is told Yeah, the escape velocities of two planets A and B are in the ratio 1:2. So escape velocity V1 by V2 that is equal to 1 by 2. If the ratio of their radii is respectively 1:3 means R1 by R2 that is equal to 1 by 3. In the ratio of acceleration due to gravity on planet A to that on the to the acceleration of gravity of planet B. So GA by GB that we have to find out means G1 by G2 that we have to find. Now G1 by G2 that will be equal to G1 by G2. Now we can say that escape velocity is given as root 2 GR, root 2 GR. Therefore, V1 by V2 that is equal to root 2 G1 R1 by root 2 G2 R2. 2 and 2 will cancel out. So this is given as 1 by 2, which is equal to root over G1 R1 by G2 R2. So it means that V1 by G2 into R1 by R2 that is equal to 1 by 4. Means that G1 by G2 will be equal to 1 by 4 into R2 by R1. R2 by R1 is 3 by 1. So hence G1 by G2 will be equal to 1 by 4 into 3, which is 3 by 4. So the ratio will be 3 by 4. So option C is the correct answer. Then it is told that for a body projected at an angle theta with the horizontal from the ground, choose the correct statement. The gravitational potential energy is maximum at the highest point, which is true. The gravitational potential energy is maximum, yeah, that is true. Then the vertical component of momentum, vertical component of momentum is maximum at the highest point. But at the highest point, the vertical component of the momentum will be zero. Means only px will be there, which is m into u cos theta. U cos theta. Now the horizontal component of the velocity is zero at the highest point, which is also false. So the p is also false. That the vertical component of the momentum is maximum. The kinetic energy is zero at the highest point of projectile motion. It is also false. So gravitational potential energy is maximum at the highest point, which is true. So option A only is the correct statement. In here it is told if Earth has a mass 9 times and radius twice to that of planet B, then E by 3 root x meter per second will be the minimum velocity required by a rocket to pull out of gravitational force of P. The V is the escape velocity of the Earth. So it means the Earth's mass is 9 times the mass of that planet, and radius of the Earth is twice of that radius of that planet. So it means mass of the planet that is equal to mass of the Earth by 9, and radius of the planet is the radius of the Earth by 2. So now therefore the new velocity required therefore the minimum velocity that is required to escape pull out of the gravitational force of T. E is the escape velocity. E is equal to E is equal to V is equal to root over 2 Gm by R. the escape velocity on that planet will be root over 2 g mp by r_t, and Ge is root 2 g me by r. So this will be equal to root over 2 g mp, that is me by 9, divided by r3, that is equal to re by 2. So which is equal to root over 2 by 9 into root over 2 g mp by me by re Vp. So therefore Vp, that is equal to root over 2 by 9 times over 2 by 9 times Ve, which is equal to root 2 by 3 into Ve. So therefore x is equal to 2 actually. Since it is 2, this is equal to root x by 3 into Ve. So therefore x is 2. So the value of x is 2. So option C is the correct answer. Then here it is told, given below are two statements. Statement 1 is acceleration due to gravity is different at different places on the surface of the earth. So it is true. As soon since the value of g, it depends on the height and on the depth. It depends on the height from the earth surface and also on the depth below the earth surface. So it is the value of g is different at different places on the earth. Then statement 2 is acceleration due to gravity increases as we go down below the earth surface, which is also true. Acceleration due to gravity increases, it is false, since by it the acceleration due to gravity it decreases as we go down the earth's surface. Since if we draw the graph of g with r, and r is the distance from the center of the earth, so the graph will be somewhat like this. So at the surface of the earth means at r equal to r. Since y on the surface of the earth, the distance from the earth's center is equal to the radius of the earth. So at the surface of the earth, the value of g is maximum, is 9.8 meters per second square. But as we go down, then the g value decreases, and when you go at a height, then also the g value decreases. So statement 2 is false. Statement 1 is true. So statement 1 is true, and but statement 2 is false. So option D is the correct answer. So here it is told that body weight W is projected vertically upwards from Earth's surface. Body having weight W is projected upwards from Earth's surface to reach a height h above the Earth, which is equal to 9 times the radius of the Earth. The weight of the body at that height will be the weight of the body at that height will be the weight of the body at that height will be weight of the body at that height will be weight of the body at that height will be weight of the body at that height will be how much? So the weight of will be equal to weight in the actual weight of the surface into r square by r plus h whole square. Since we know that the value of g at a height is given as g on the surface into r square by r plus h whole square. And r is the radius of the earth and h is the height from the surface of the earth. So therefore, the weight will be equal to W, which is the body weight on the surface of the earth. Which is equal to W into r square by r plus 9r into those r plus 9r square. So this is W into r square by 10 r whole square, which is 100 r square. So the r square will cancel w by. So option C is the correct answer. And here it is told at a depth d below the surface of the earth, the value of acceleration due to gravity becomes 4 times of that of its value at a height 3r above Earth's surface. A certain depth d below surface of Earth. Value of acceleration due to gravity becomes 4 times that of its value at a height 3r above Earth's surface. So at a depth d, the value of acceleration due to gravity g d, that is g into 1 minus d by r, that becomes 4 times of its value at a height 3r above the Earth's surface. So 4 into g into r square by r plus 3r whole square. But r is the radius of water. Take r as 6,400 meter. The depth d is equal to r. So therefore g and g I can cancel out. So 1 minus d by r, that is equal to 4r square by 4r whole square is 16r square. So r square will cancel. 4 is 16. So it means that 1 minus d by r is equal to 1 by 4. So it means that d by r will be equal to 1 minus 1 by 4, which is equal to 3 by 4. So d is equal to 3 by 4 r. 3r by 4, which is 3 by 4 times the radius of earth, which is 6,400 kilometer, which is 416, 64. So 1600 into 3, that is 4,800 kilometer. So option D is the correct answer. Then it is told an object is allowed to fall from a height r above the earth that r is the radius of the earth. Its velocity when it strikes the earth surface, ignoring air resistance, will be. So with what velocity? So we can say that the gain in kinetic energy is equal to the loss in potential energy. So the gain in kinetic energy is final kinetic energy minus initial kinetic energy equals to loss in potential energy, means initial potential energy minus final potential energy. So final kinetic energy is half mv square, and it is uh, allowed to fall from a height. So here initial velocity is 0. So half mv square minus 0, that is equal to the initial potential energy, which is minus gmm by 2 into r. R is r plus h minus of minus gmm by, no, which is 2 is not there, minus gmm by r. So it is minus gmm by r. Since when it reaches the earth's surface, then r is equal to r. And when it is at a height, then r is equal to r plus h, which is 2r here. So therefore, m I can cancel out, where m is the mass of the object. So I can say g square by 2, that is equal to gm by r minus gm by 2r. So therefore, b square by 2, that is equal to gm by 2r. Gm by 2r. So 2 and 2 will get cancelled. So v will be equal to root over gm by r. So therefore, v will be equal to root over gm, that is gr square by r, that is equal to root over gr. So root over GR. So option B is the correct answer. Then here it is told that if the gravitational field in the space is given as minus k by r square, means we are taking the reference point to be r equal to 2 centimeter, the gravitational potential B is equal to 10 joule per kg. Find the gravitational potential at r equal to 3 centimeter in this unit. We know that the gravitational field E at r is equal to given as minus du by dr. So find the gravitational potential. So we can say that EV is equal to minus E into VR. So if we integrate it, then we get from V at r equal to 2, r equal to 2, okay, initial and V final, r equal to 3, r equal to 2, and this is r equal to 3. Means V final minus V initial means V at r equal to 3, we have to find out gravitational potential at r equal to 3. Means gravitational potential at r equal to 2. That is equal to minus integral minus k by r square into dr at 2 to 3. So means V final, which is V at r equal to 3 minus V at r equal to 2, which is 10 joule. So it is 10 joule per kg. That is equal to k by k into integral dr by r square 2 to 3. So it means that V minus, we take it as V minus 10, that is equal to k into, this is minus 1 by r 2 to 3. This will be k into field is given as okay, and field at infinity it will be 0. So it will be k by r integral minus k by r square dr from r to infinity to r. That will be k into 1 by minus 1 by r, 1 by r infinity. So this will be minus k by r. That k by 2 value, that is equal to 10. So k is equal to 20 joule centimeter per kg. Okay, so k value has been told, which is 6 joule centimeter per kg, which is 6 joule centimeter per kg into minus 1 by r. So is 1 by 2 minus 1 by 3, which is to be a 6, which is 1 by 6. So it is 1. So V is equal to 11 joule per kg. So B is the correct answer. It is told that the time period of the satellite of Earth is 24 hours. The separation between the Earth and the satellite is decreased to 1/4 of the previous value. If the separation between the Earth and the satellite is decreased to 1/4 of the previous value, then the new time period will become. So you know that T square is directly proportional to R cube. So it is told that the new time period when the separation is decreased to 1/4. So it means the new separation R, that is R by 4. So then the new time period is, let's say, T1, so which we have to find. So we can say that T1 square by T square, that is equal to R1 cube by R cube. So therefore I can say that T1 square divided by T square, which is 24 square, that is equal to R1, that is R by 4 by R over cube. It means that T1 square by 24 square, that is equal to 1 by 4 cube. Square, that is equal to 1 by 4, 16, 64, 64, 64 into 24 square. T1 square, that is equal to, yeah, so T1 square, that is 24 square by 80 to 64, so 8 square. Means T1 would be equal to 24 by 8. So 3 hours. So 3 hours will be the new time period. So option C is the correct answer. Two particles of equal mass m move in a particle of radius r under the action of their mutual gravitational force. So two particles are there having masses m, they move in a circle of radius r under their mutual gravitational attraction. Speed of each particle will be, so the speed will be same v and v, and then we can say that their mutual gravitational force, so that is gm square by 2r whole square, that is equal to the centripetal force, which is Lv square by r. Therefore, I can say that when it get cancelled, so v square by r, that is equal to Gm by 4r square. If r was cancelled, so v will be equal to Gm by 4r. So option A is the correct answer. Here it is told match list 1 with list 2. So here it is told every planet revolves around the sun in an elliptical orbit. Force acting on a planet is inversely proportional to square of the distance from the sun. Force acting on a planet inversely proportional to the square of the distance from the sun. It is true since the force is V equal to V into mass of sun and the mass of the planet by r square. So then the force, so A is true, then force acting on a planet is inversely proportional to the product of the masses of the planet and the sun, which is false, since it is directly proportional to the product of the mass of the planet and the sun. The centripetal force acting on a planet directed away from the sun is true, which is false. Since right, the centripetal force will act towards the sun, since it will act always towards the center of the circular path. Then the square of the time period of revolution of the planet around the sun is directly proportional to the cube of the semi-major axis of the elliptic line. Yeah, we know that it is t square is proportional to r cube, which is the Kepler's law of periods, which tells that the square of the time period of revolution is directly proportional to the cube of the semi-major axis of the elliptic orbit. So hence B is also true. So only A and D are true and B and C are false. So choose the correct answer. So it will be A and D. Option C is the correct answer. And here it is told body of mass m. Body of mass m is taken from Earth's surface to height h equal to twice the radius north. the increase in potential energy will be the increase in potential energy you find. So that is the final potential energy minus the initial potential energy. So it is taken from the Earth's surface. So initially, the gravitational potential energy is Gm into m by r square. No, minus Gm by r, and the final potential energy will be minus Gm m by r plus h, and height is 2r. Therefore, I can say this will be Gm by r minus Gm by 3r. So it means that Gmn by r I can take as 1, and that into 1 minus 1 by 3 is equal to 2 by 3. It is equal to 2 Gmn by 3r. So Gm means that it is equal to gr square. This would be equal to 2 by 3, 2 by 3 m into gr square by r. So this would be equal to 2 by 3 mgr. R is Re actually, which is the radius of the Earth. So it means option D is the correct answer. So this is the required increase in the potential energy when it reaches the height equal to twice the radius of Earth. And here it is told, assume that the Earth is a solid sphere. Earth is a solid sphere of uniform density, and a tunnel is dug along its diameter through the Earth. So one tunnel is dug. It's found that when a particle is released in this tunnel, it executes a simple harmonic motion. The mass of the particle is 100 gram. Mass of the particle is 100 gram. The time period of motion of the particle will be approximately time period of motion of the particle will be approximately here net force will be equal to G and will be equal to at when it is at distance x from the center. So then the force that it will experience, that is equal to G into mass of the Earth by volume, which is 4 by 3 pi r cube. This is the density. Density into volume, which is 4 by 3 pi x cube. This is the mass of the inside part to m by x square. So therefore, this will be 4 by 3 by 4 by 3 pi cancel. So this will be equal to G m m x by r cube, which is equal to the form of kx. So I can say mass into acceleration, that is equal to G m m by r cube into x. So m we can cancel out. So a we know that is equal to inverse square x for simple harmonic motion. I can say that the acceleration is Gm by omega square, that is equal to Gm by r cube. So therefore, omega that will be equal to root over Gm by r cube. time period will be equal to root over r cube by gm. And gm that is equal to g r square. So that is root over r by g, which is equal to root over r, which is 6,400 into 1000. That's divided by e, that is 10. So this is equal to 64 into 10 power 4 by 1. So this is equal to 8 into 10 power 2, which is 800 seconds. It's equal to 400 kilometer. So t is equal to 2 pi by, so t is 2 pi into r cube by g r square. So into 2 pi also have to do this into 2 pi into this. So this into 2 pi. So therefore, the required time period, that is equal to 2 pi into 2 pi into 800 seconds is equal to 6. If to convert into hours, so this will be equal to 1600 pi 5 divided by 6,600 seconds, since 1 hour is 6,600 seconds. 0 will get cancelled. So 4 4 is 16, 1 9 is 36. So this is 4 by 9 into 5 hours. 4 by 9 into 5 hours. So this is equal to approximately pi. I can say this is approximately 3. So 3 4 are 12, 12 by 9 hours approximately, which is 0.9 3 4 are 12. So it is 1 by 3 hours. So we can say which is approximately 1 hour 3 to the 6, 1 hour 20 minutes approx. 1 hour 24 minutes, I can say. Option B is the correct answer. Option B is the correct answer. Then here it is told the assertion is pendulum clock when taken to Mount Everest becomes fast. So we know that t equal to 2 pi root over L by g. So in the top of the Mount Everest, the g will decrease, so the time period will increase. The time period will increase, it means the clock will become slow. So it will not be fast, it will become slow. So the assertion is false. Then the reason is the value of g acceleration due to gravity is less at Mount Everest than value on the surface of Earth, so which is true. So the reason is true. So the assertion is false. So therefore, option D is the correct answer. That A is not correct, but R is correct. And here it is told if the planet, if the distance of the Earth from the Sun, the distance of the Earth from the Sun, that is R equal to 1.5 into 10 power 6 kilometer, then the distance of an imaginary planet from the Sun, if its period of revolution is 2.83 years, is then the distance of an imaginary planet from the Sun, if its period of revolution is 2.83 years. So we know that T square is proportional to R cube, which is the Kepler's law of periods. So we know that the time period of revolution of the Earth is 1 year. The time period of revolution of that planet, we have to find out if the distance of that planet from the sun, that is that we have to find out the time period of the planet. The time period of revolution of the planet is given as 2.83 years. Then the distance of this imaginary planet from the sun that we have to find. Therefore, I can say the time period of the Earth square by time period of that planet square, that is equal to time period of that planet square by time period of Earth square, that is equal to the distance of that planet from the sun cubed by the distance of the Earth from the sun, its cube. So therefore, I can say TP square is 2.83 square by 1 square, since the time period of the Earth is time period of revolution of the Earth is 1 year. So this is equal to RP, which we have to find out. So RP cube divided by RE, that is 1.5 into 10 power 6 meter. Okay. So therefore, I can say that RP cube, that is equal to 1.5 into 10 power 6 kilometer per cube into 2.83 square, sorry. Which is now therefore RE, that would be equal to 1.5 into 10 power 6 power 6 into 2.83 in power 2 by 3. So this RP only you have to find out. So 2.83 power 2 by 3 that you find out. So it's power equal to approximately 2. This is, so you can say RP, that is approximately, this is 3 into 10 power 6 kilometer, approximately. 3 to 10 power 6 kilometers. So option D is the correct answer. Now, here it is told given below are two statements. Statement one is acceleration due to gravity decreases as you go up or down in the Earth's surface. Yeah, since we know that the graph of acceleration due to gravity with the distance from the center of the Earth, that is somewhat like this. So here you can see that at the surface of the Earth, which is where R equal to R, then only the acceleration due to gravity is maximum. And as we go at a depth or at a height, then the acceleration due to gravity will decrease. And statement 2 is acceleration due to gravity is same at a height h, and take t from the Earth's surface if h is equal to t, which is false. This false since well, acceleration due to gravity at a height is given as g into square by r plus h whole square. That comes r plus h whole square, and that should be equal to g into 1 minus d by r. So hence there can be any values of h and r, h and d, for which the acceleration due to gravity will be the same. It means that statement 1 is true. So statement 1 is correct, but statement 2 is incorrect. So option A is the correct answer. It is told the weight of a body at the surface of the earth. The weight of a body at the surface of the earth, mg, that is 18 Newton, and the weight of the body at an altitude of 3,200 kilometers above the earth's surface is weight of the body at an altitude of height which is 3,200 kilometers above the earth's surface, which is actually equal to half of the radius of the earth. Therefore, the weight, new weight at that height, that will be given as W dash equal to W into d by it's W into r square by r plus h whole square. Since we know that g at a height is given as at a height h is given as g into 1 g into r square by r plus h whole square into r square by r plus h whole square. Then the height that is equal to r by 2. So therefore, the new value of g at that height, that is given as r square by r plus r by 2 is r plus r by 2, which is 3r by 2, 3r by 2 whole square, which is equal to 4g by 9 g at this height. Therefore, the new weight that will be equal to w into w into r square by r plus h whole square. Since y w is mg dash, is mg dash, that will be equal to mg into r square by r plus h whole square. G dash, that will be equal to g into r square by r plus r by 2, so 3r by 2 whole square is equal to mg, that is w into 4 by 9. So the weight is given as 18 newtons, so 4 by 9 into 18, which is 9 to the 18, so 8 newton. So option D is the correct answer. Then it is told if the Earth suddenly shrinks to 1/64th of its original volume while its mass remaining the same, the Earth suddenly shrinks to 1/64th of its original volume. So the final volume is 1/64 of the initial volume. With its mass remaining the same, you know, mass is remaining constant. The period of rotation of the Earth becomes 24 by x hours, the value of x is. Now we can say that in case of rotation, the angular momentum of the Earth's rotation that will remain constant. So I can say that I omega that will remain constant. So where I is the moment of inertia of the sphere. So I can say that I1 omega 1 that is equal to I2 omega 2. So I1 that will be equal to moment of inertia the sphere with the moment of inertia of the sphere. This would be equal to 2 by 5 mr square, by 5 mr square into omega initial, that is equal to I2, which is 2 by 5 m into r1 square into omega 1, where omega 1 is the new angular speed. Maybe I can say this 2 pi by t. This would be equal to 2 pi by t1. 2 pi will cancel. 2 pi 5, 2 by 5 n that will also get cancelled. So you can say that 1 by t1 r1 square by t1, that is equal to r square by t. Therefore, the new time period, that is t1, that is equal to r1 square by r square into t. Therefore, t1, that will be equal to r1 square final volume, that is 4 by 3 pi r1 cube, that is equal to 1 by 64 times, by 64 times the mean, that is 4 by 3 pi r cube. If by 3 by 4 by 3 pi will get cancelled. So r1 cube, that is equal to r by 4 cube. It means that r1 will be equal to r by 4. That means that r1 by r, that will be equal to 1 by 4. So by 1 by 4 whole square into t, so this would be equal to t by 16. So t1, the new time period will be equal to 24 by 16 hours. So x will be 16. So 16 is the answer. Then here it is told that an object of mass 1 kg is taken to a height surface of Earth, which is equal to 3 times the radius of the Earth. The height is 3 times the radius of the Earth. The gain in potential energy of the object will be if G is equal to 10 meter per second square and radius of the Earth is 6,400 kilometers. So the gain in potential energy, that is equal to the final potential energy at that height minus the initial potential energy at the surface. So the final potential energy at this height, that will be equal to minus G m by, n is the mass, small m is the mass, and capital M is the mass of the Earth, where Gm I can write that is equal to G r square. This is minus Gm by r plus h, which will be equal to minus Gm by r plus 3r, which is 4r. This would be minus Gm by 4r minus of the initial potential energy, which is minus Gm by r. So this will be equal to Gmm. So this will be equal to Gmm by r minus Gmm by 4r. So therefore, the increase in the gain in the potential energy of the object, that will be equal to, we can take Gm by r as common. This will be 1 minus 1 by 4, that is equal to 3 by 4. So this is 3 by 4 into r square into m by r. So r will get cancelled. Therefore, gain in potential energy, that will be equal to 3 by 4 into mgr, which will be equal to 3 by 4 into m is 1 into g, that is 10, into r, that is 6,400 kilometers. So 6,400 into 10 power 3. This will be 416 4 by 64. This will be 316 3 are 48. So 4,800, 48,000 into 10 power 3. This will be equal to 48 into 10 power 6 joule. Is equal to 48 megajoule. Since 1 megajoule is 10 power 6 joule. So it is 48 megajoules. So option A is the correct answer. And it is told if the radius of Earth shrinks by 2% while its mass remains same. The radius of the Earth shrinks by 2%. It means the wave radius R1 that is equal to R minus 10 minus 2% of R. Means that will be 98% of R. The R I can say it is the initial radius which is equal to 0.98 R. This is R1. The acceleration due to gravity on the Earth's surface will be approximate. Mass remains same. So we know that acceleration due to gravity is g1 by r squared. So its mass remains the same. It is stored. Now the amount of increase in the when radius of the Earth decreases, then the value of g will increase. So now since the amount of decrease is very small, so I can say that delta g by g that is equal to minus 2 delta r by r. So therefore, the percentage increase in the, you can say percentage increase in g that is equal to 2 times the percentage decrease in the radius. So the percentage decrease in the radius is 2%. So the percentage increase in g will be 4%. So there is 4% increase the value g. So acceleration due to gravity on the Earth will approximately increase by 4%. So option B is the correct answer. And it is told a body of mass m is projected with velocity lambda v. Body of mass m is projected. A body of mass m is projected with a velocity lambda v in vertically upward direction. In vertically upward direction, this term is equal to lambda v. The surface of the Earth into space. Swung vertically upward from the surface of the Earth into the space. It is given that v is the escape velocity and lambda is less than 1. If air resistance is considered to be negligible, resistance is negligible, then the maximum height from the center of the Earth to which the body can go is. So when it will go to the maximum height, then its kinetic energy will become zero. I mean, kinetic energy will become zero. So we can say that the gain in potential energy, that will be the loss in kinetic energy. So I can say the final potential energy minus initial potential energy, that is equal to the initial kinetic energy minus the final kinetic energy. Since loss means initial minus final and gain means final minus initial. So therefore, the final potential energy when it will reach a height h, that will be equal to minus g mm by r plus h. The height only has been asked, the maximum height from the center of the Earth, which we can go again. So it is minus gm by r plus h minus this is initial potential energy which is minus gm by r, that is equal to the initial kinetic energy which is half mv square minus 0. Final value is 0. So it means I can say half mv square, that will be equal to, you can say V, that is equal to actually root 2 gm by r. Therefore I can say e square by 2, e square by 2, that is equal to gm by r. So this is actually half m into lambda square ve square, that is equal to gmm by r minus gmm by r plus h. So mass we can cancel, m we can cancel out. So therefore I can say that lambda square by 2 into e square, that is e square, that is 2 gm by r, 2 gm by r, that is equal to gm by r minus gm by r plus h. Therefore gm I can cancel out. Therefore I can say, and so this would be 2 I can cancel. So this will be lambda square by r equal to 1 by r minus 1 by r plus h. So I can say 1 by r plus h, that is equal to 1 by r minus s per by r. So 1 by r plus h, that will be equal to, you can take r as the LCM. So this will be 1 minus lambda square. It means that r plus h equal to r by 1 minus lambda square. Hence why here it is told lambda value is less than 1. So this is obvious. This is obviously greater than 0. So h should be equal to r in r by 1 minus lambda square minus r. So this will be equal to r minus r plus r lambda square by 1 minus lambda square. So this will be equal to r lambda square by 1 minus lambda square. R lambda square by 1 minus lambda square. So the height from the surface will be r. So that is equal to lambda square r by 1 minus lambda square. So option D is the correct answer. Then here it is told two satellites A and B having masses in the ratio 4:3 are revolving in circular orbits of radius 3r and 4r respectively around the Earth. Ratio of total mechanical energy of A to B is. So the total mechanical energy that is given as minus gmm by 2r. 2r. R is the radius of the orbit, and m is the mass of the, small m is the mass of the satellite, and capital M is the mass of the Earth. This part is constant, so I can say that total energy that is directly proportional to m by the magnitude of the total energy that is directly proportional to m by r, where m is the mass of the satellite, r is the radius of the circular orbit around the Earth. So therefore, the ratio of the total energy of A by the total energy of B, that is equal to mass of A by radius of A, radius of the orbit of A by mass of B by radius of orbit of B, which is equal to mass of A by mass of B into radius of B by radius of A. So mass of A by mass of B, that is given as 4 by 3, and radius of B, that is 4r, radius of B, that is 3r. So that is also 4:3. So R will cancel. So this will be 16 by 9. So the required ratio is 16:9. So option B is the correct answer. Then it is told body is projected vertically upwards on the surface of the Earth with a velocity equal to one-third of the escape velocity. The maximum height that will be attained by the body. So what height it will reach, that we need to find out. So finally, the kinetic energy will be equal to zero at the maximum height. So we can say that the gain in potential energy, that is equal to the loss in kinetic energy. So the gain in potential energy means final potential energy minus initial potential energy, which is at the surface of the Earth. That is equal to the initial kinetic energy at the surface of the Earth minus the final kinetic energy of the at that axis. That should be zero. So now it means the final potential energy that will be equal to minus Gmn by r plus h, then minus the initial potential energy at the surface of the Earth, that is equal to minus Gmn by r, that is equal to the initial kinetic energy, which is half mv square. The initial kinetic energy is equal to half mv square of mv square. So V is equal to G by 3. Now V I can say, which is the escape velocity, that is equal to root 2 Gm by r. So E is equal to V by 3. It means this will be V square, that will be equal to VE square by 9. This will be equal to 2 by 9 into Gm by r. Means I can say this will be Gmm by r minus Gmm by r plus h. That will be equal to half m into 2 by 9 Gm by r. 2 will get cancelled and m also will get cancelled, and Gm by r also I can cancel it. So then here I can write Gm by r into r will come, right? This will get cancelled. Therefore, we can say this will come 1 minus r by r plus h. That is equal to 2 by, that is equal to 1 by 9. 1 by 9. So therefore, I can say r by r plus h, that is equal to 1 minus 1 by 9, which is equal to 8 by 9. You can say 9r, that is equal to 8r plus 8h. So it means that 8h is equal to r, so h should be equal to r by 8. Is equal to r by 8. So therefore, the required height will be equal to r by 8, which is 6,400 kilometer divided by 8, which is 800 kilometer. So option A is the correct answer. Then it is told the percentage decrease in the weight of a rocket when taken to a height of 32 kilometer above the surface of the Earth will be. So the 32 kilometer means it is r by 200. So this height is extremely small than the radius of the Earth. So it means the value of g dash at that height, that will be equal to g into 1 minus 2h by r. Since g into approx, g dash is approximately g into 1 minus 2h by r. Since here h is much less than r, since here h is radius of the Earth by 200. So it means this is much less than r. So we can use this formula. Therefore, now percentage decrease in the value of g, that is same as the percentage decrease in the weight. Since y weight is equal to mg, mass will not change, only g will change. So therefore, the percentage decrease in g, that is same as the percentage decrease in the weight. The percentage decrease in g, that will be equal to g dash g minus g dash by g into 100%. It means it is 1 minus g dash by g into 100%. Means it is 1 minus g dash by g, that is equal to 1 minus 2h by r, obviously. This will be 1 minus 1 minus 2h by r into 100%. So this will be equal to 1 minus 1 plus 2h by r. So 1 will get cancelled. This will be minus of minus is plus, so 2h by r into 100%. So therefore, the required percentage decrease in the weight, that is equal to 2 by r into the height, which is r by 200. Since y 32 kilometer is 6,400 kilometer divided by 200. That is r by 200 into 100%. This will be 2, this will be 100, or I will cancel 100, 100. So this is 1%. So there is 1% decrease in the weight. So option A is the correct answer. And it is told the length of a simple pendulum at a height h is equal to 2 or a surface will be. Length of a simple pendulum, the height h equal to 2 of the surface will be. So if it has to give the same time period, so it means that the time period should remain the same. So it means we know that t is equal to 2 pi root over L by g. So t should remain same. So then it means so it means L by g value should remain the same. So it means I can say that L1 by g1, that will be equal to L2 by g2. I can say that length of a simple pendulum should be a seconds pendulum. So it means the time period will be 2 seconds. Since why it should be a simple seconds pendulum. Seconds pendulum. That means 100 is 2 seconds. I will say 2 into 3 5 into root over L by g. G at a height of the, so g dash I have to use. So g dash will be equal to g r square by g by r plus h whole square, which is equal to g into r square by r plus 2r. So 3r whole square, that is 9r square. So r square cancel, which is equal to g by 9. So g dash, that is g by 9. So g by 9, so it will be 2 is equal to 2 pi root over 9 L by e, that is pi square. It means that I will say 2 will get cancelled. So I will say that pi by pi into 3 into root L, it is equal to 1. So pi will get cancelled. So root L is equal to 1 by 3. So N will be equal to 1 by 9. So 1 by 9 meter is the length of the seconds pendulum at the height of 2r from the Earth's surface. So option D is the correct answer. Then it is told that an object is taken to a height above the surface of the Earth at a distance 5 pi r from the center of the Earth. An object is taken to a height above the surface of Earth at a distance of 5 r by 4 from the center of the Earth. is taken to a height. So the distance 5r by 4. Okay, so it means that h will be equal to 5r by 4 minus r, that is equal to r by 4. So the height from the surface of x is r by 4, and from the center it is 5r by 4. R is 5r by 4. Where radius of earth is 6,400 kilometers, the percentage decrease in the weight of the object will be. So now percentage decrease in the weight, that is, since weight is mg, so it means it is same as the percentage decrease in the run of g. So that is equal to g minus g dash by g into 100%. So now g value, g dash at the height, that is equal to g into 1, g into r square by r plus h whole square. So now g dash will be equal to g into r square by, this is r plus h, that is r, that is 5r by 4 whole square. This will be equal to 16 by 25 g. 16 by 25 g. This will be equal to g minus 16 by 25, 16 by 25 g divided by g into 100%. This will be g will cancel 1 minus 16 by 25, that is 9 by 25 into 100%. So that is 25 floors 100 and 36%. So the percentage decrease in the weight, percentage decrease in the weight of the object will be 36%, which is option A is the correct answer. Then so three identical particles A, B, and C of mass 100 kg each are placed in a straight line with AB equal to BC is equal to 13 meters. So this is ABC. A, B, and C. AB and BC are same, that is 13 meters. So AB and three identical particles are placed, M, M, and M. The mass is 100 kg. There is in a straight line. The gravitational force on a fourth particle P of the same mass is when placed at a distance 13 meters from the particle P in the perpendicular bisector of the line EC. So it means here it is placed, here the point P, this is kept at a distance 13 meters from here. The value of F will be approximately. So its mass is also same, which is 100 kg. The net gravitational force of this fourth particle, due to all these three particles, will be mutual. So this way, one force will act. Is, let's say, F1. This force will act. This mass A will attract B with one force, let's say F2, and C will also attract B with the same force F2. So this angle is 45 degrees. This is also 45 degrees. Since this length and this length is same, so it is an isosceles right angle triangle here. So this component will be F2 cos F2 sine 45. This is equal to F2 sine 45, which will get cancelled. This 2 will get cancelled. And now this way, the net force, which is F on the fourth particle P, the net force F net, which is F, what is given as F, we have to find that, the approximate number of F as the unit. So F will be equal to F1 plus 2 F2 cos 45 is equal to F1 plus 2 F2 into cos 45, which is 1 by root 2. So it is F1 plus root 2 into F2. Now F1 is the magnitude of the force by which P attracts P. So that is Gm square by x square, L square, I can say, where L is 13 meters and M is 100 kg. And F2, that will be equal to Gm square by, this is L, so this is root 2L, so this is root 2L whole square. So that is Gm square by 2L square. So this is Gm square by 2L square plus root 2 into Gm square by L square. Root 2 into Gm square by L square. So this will be equal to Gm square by L square into 1 by 2 plus root 2. So this is the net force F. So therefore, the force F, that will be equal to G into M square, that is 100 square, that is 10 power 4, divided by L square, that is 13 square, into half, that is 0.5 plus root 2, that is 1.414. This is equal to 1.914 into 10 power 4 divided by 13 square into G, which is approximately 19140 by 13 square, which is 169 into G. So this is approximately, therefore the force that is coming, that is approximately 19140 by 169 into G, where G is the universal gravitational constant. So this is approximately which is approximately 113 G. 113 G. So I can say it is approximately 100 G. Sorry, this is root 2 F2. Root 2 F2. F2 is Gm square by 2L square. F1 is Gm square by L square. This is wrong. So this should be 1 plus root 2 by 2. Well, this is here. Gm square by L square. So this will be Gm square by L square plus 1 plus root 2 by 2. This will be Gm square by L square. 1 plus 1 by root 2. Therefore, the force here, that will be equal to G into 100 square by 13 square into, this is 1 plus root 2 by 2, that is 1.414 by 2, that is 2 7 the 14, 2 7 the 14. This is 1.707 into 10 power 4 divided by 13 square into G. This will be 17070 by 169 into G. This will be approximately 7070 divided by 169. So this is approximately 101 G, which is approximately 100 G. Option D is the correct answer. Then here it is told the radii of two planets A and B are in the ratio 2:3. The radii of two planets A and B. The radii of two planets A and B are in the ratio 2:3. Their densities are 3 rho and 5 rho respectively. The ratio of their acceleration due to gravity. So acceleration due to gravity is gm by r square. So this will be equal to g into 4 by 3 pi r cubed into rho by r square. So this is equal to 4 by 3 pi g into rho r. 4 by 3 pi g into rho r. So therefore, I can say the acceleration due to gravity is directly proportional to the density of the planet into radius of that planet. So therefore, the ratio of the acceleration due to gravity means the acceleration due to gravity of A by acceleration due to gravity of E that we have find out. So this is the density of A into the radius of A by the density of B by the radius of B. So which is equal to now density of A that is given 3 rho and the radius of A that by the density of B that is 5 rho into the ratio of radius of A and radius of B that is 2 by 3. So this will be equal to rho and rho will cancel, 3 will cancel. So this is 2 by 5. So the required ratio is 2:5. So option D is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter gravitation. Still any doubts if you have, please write that in the comments. You should obviously clarify them. And in any other chapter of physics, if you have more difficulty, please write the name of that chapter in the comments. We should so that we can create more clarity on it and solve more and more questions on that chapter, which shall be obviously helpful for us. So thank you everyone. Bye.